Hi everybody, let's start this class. So in today's lecture we are going to be starting up chemical kinetics, and just for your kind information I would like to tell you that we have actually completed solution chapter in 3 sessions. These 3 sessions were long enough to complete the whole chapter, and this is what we have done in the previous alternate days. So I always take classes for class 12 students, 12th standard students on Tuesday, Thursday and Saturday 9 p.m. and for 11 students I do take classes on Monday, Wednesday, Friday. So this is the timing for chemistry on our channel. Similarly, it goes with the physics as well at 6 p.m. So you should make sure that you can actually subscribe to the channel and you actually come regularly to make your preparation best. So hi Lakshmi, hi Khushi, welcome to the session. You can also let me know if there's anybody who actually has completed their class 12th chemical kinetics chapter. How was it for you? Is it tough, medium, easy, or is it like you haven't gone through it yet? Because don't worry, no matter at what particular stage you are at for this chapter, I am going to make it easy for you till the end. Okay, so do watch regular sessions. So today we are doing up on Saturday, then we will be doing up on Tuesday, then Thursday and again Saturday. Okay, my aim is to complete this chapter again for you in 3 classes. I think it can be 4 as well, but still I hope that it goes well in 3. Okay, amazing. So over here, let's start this particular class. Entire topics in the chapter. Yes, I am actually completing all the topics in the chapter. That's the reason I'm saying that the classes are slightly longer. So instead of taking 1 hour classes, the classes are of 2 hours. So giving 6 hours to solutions, it's more than enough, because the topics that are coming in JEE are totally predictive. There are a lot of most repeated topics from solutions. I've covered each and everything. Okay, and if you need more practice problem solving, I am going to be bringing up that as well. Okay. Luv Mehan sir, tomorrow leave or so anyhow, tomorrow it's not leave. Tomorrow I'll be taking up classes again, but those classes are going to be like, there's a session that I'm going to take tomorrow which is going to be one shot IUPAC nomenclature and isomerism from GOC. So I'm taking organic tomorrow. So that and the problem solving on special classes. So tomorrow it is going to be a special class at 7 p.m. where I am going to be bringing up questions for the students from both the topics, the IUPAC nomenclature and isomerism, so that you guys can actually practice. But anyhow, for those who are watching me for the first time, do follow my Telegram channel and do follow me on Unacademy as well. Apart from this, there's one more Telegram channel that you should join for physics as well as chemistry content, JEE English by Unacademy. And do remember, if you're looking for a batch to get enrolled, if you are a 2023 or a 2022 student, even droppers, then we have Shine batch and Spark batch where all the classes are going in English. And you should remember, if you use my code, then ultimately you will be getting up mentorship from my end. And who am I? I am an ISCN. I've taught and mentored 50,000 plus students online. I had been a researcher before being a teacher. My own all-India rank had been 361 in GATE 2017. And over here guys, 2022 students, this month is too good for you, because every week you can actually see a lot of batches starting up for you guys. So do not worry that how the studies are going to be for you. Everything is going to be the best, because ultimately you should know, over here we have the best educators, and USET is what you have to give. This USET is going to happen on 11th and 12th. So today it happened, tomorrow also it's going to happen. So do remember to give USET examination, because top 1000 rankers are going to get up to 100% scholarship. The pattern is absolutely easy. It's a JEE pattern, 90 questions, 180 minutes, and the ones who are going to get rank between 1 till 1000, you guys are going to be getting up scholarships, and this is where the things will become easier for you. But anyhow, you should remember, on Unacademy plus and Iconic, what all benefits do you get? So over here guys, pay attention, and these wires, let's remove it. Okay, you get India's best educators, you get their live classes, that is common. You can ask doubts in the live classes, you get notes and PDFs, and all the courses are structured, so you actually know when are these classes going to end, when are the courses going to end, and tests and quizzes are available to you which is actually going to take you to the another level. And apart from this, in Iconic you get personal coach, study planner, study material, expert guidelines, test analysis, and a lot of benefits which are not available in Plus. So but anyhow, if there is a student who is good enough, disciplined, have a good control over self-study as well, Plus is good for you. And if you are the one who really think that there are less people around you to mentor you, Iconic is one for you. Over here I am going to recommend 12 months for 2022 and droppers, 24 months to 2023 students, and same for the Iconic as well. And you should know that you can actually get into the Iconic later as well. If you have Plus, you can later on upgrade the plan. And you should definitely remember that the EMI options are also available. No cost EMI options are also available for selected banks and cards. And yes, all the other modes of payments are also available. So do remember this. And as soon as you apply the code, which is LUVGURU, you will get extra discount. Okay? Yes? Amazing. Shall we start? So let's have some smileys in the chat. Special class tomorrow, which topic, sir? It's going to be GOC, isomerism and IUPAC nomenclature. Amazing. Let's go. So over here, guys, boys and girls, pay attention. What are we talking about? We are talking about chemical kinetics. Whenever we talk about kinetics, kinetics is for something which is in motion, I mean, something which is having some speed, something related to speed is what we are going to talk about. And what are we talking about? Chemicals, in chemistry. And why do we really need to know about chemical kinetics of any particular reaction? Is this GIF, is this image familiar to you? Who's he? Come on, let me know. Who's he? What is he doing actually over here? Simply lying, waiting. What's gonna happen? When is it going to happen? Something like that. Yes, we have Mr. Bean over here for you guys. And over here, actually, Mr. Bean is actually waiting for something to come. And this is what this is the reason why we are going to learn chemical kinetics. What exactly happens? Why do we learn that? Because there are a lot of different reactions which can give you the same result. Okay, you want a product, okay, you want a pizza. There is a pizza delivery which is going to deliver you pizza in 30 minutes. There is a pizza delivery which is going to deliver you a pizza in 15 minutes. There is a restaurant which makes a pizza in 20 minutes. There is a restaurant which makes a pizza in 10 minutes, right? Now it's actually on you, with which all services do you have to go, correct? So it's all about timing. It's all about how fast the reaction is going to complete, the process is going to get complete, and also how much time will it take, how fast, which one is fast, and which one is going to take how much time. Calculation, we should know everything. Waiting for the aeroplane on road. Yes, you know it better. Yes, absolutely correct. To check the feasibility of the reaction. It actually tells us, which one is more feasible, which one is less feasible. Whether we should actually wait for a reaction to happen. Let me know. Is it feasible to eat a pizza if that pizza comes after 4 hours when you order it? Or is it feasible for you to have a pizza which actually comes to you within 30 minutes? You know it, right? The lesser the time, that's more feasible, because time is money, right? And for factories, for industries, time is money, right? So we actually have to look for which one is a feasible reaction, how much speed, with how much quickness, which reaction is fast, and if one reaction is fast, then how much time will it take to complete the reaction, to get the final product, is what we have to remember. And apart from this, guys, mark the attendance, everybody who's there in the session. So everybody should mark the attendance by hitting up the like button. And now over here, let's talk about different types of reactions. What are we really talking about? We are talking about instantaneous reactions, which happens like this. We have an example. So explosions are also instantaneous reactions, right? And there are few chemical reactions, something like HCl and NaOH, the neutralization processes, where you actually are having two species, two components, very reactive, against each other. And as soon as you add one drop of HCl in NaOH, you get NaCl and H2O. That's how it is. Can you name a bit more of a bit different examples of instantaneous reactions in your day-to-day life? Let me know. Even it could be from a cartoon, I mean whatever you can see around you. Let's see. I am already okay. Thank you so much, Karthik. Right? So over here you should remember the most easiest example could be an explosion, right? So this is what you should really remember. Even combustion. Let's say you switch on the gas stove. The gas is there and you switch it on. The fuel gets the catches fire. It actually gives you CO2 and water. Correct? That's how it is going to be. Apart from this, let's talk about the moderate reaction. So instantaneous reactions somehow take few seconds or minutes to complete. 100% completion is what I'm talking about. Few minutes, 1 minute, half a minute, a few seconds, 2 seconds, 5 seconds, something like that. When we talk about the moderate reactions, we are talking about the reactions which take time. How much? Some hours to get complete. Okay? Any examples around you? I am actually having an example over here which is actually cooking. How much time does it take for your parents, or even if you do cook, to get a dish ready? How much time will it take for you guys to actually make Maggie? It will take few minutes, right? Or maybe if it is a dish where you actually have to marinate things, you have to prepare it, you want the dish, this or the substance. I mean, let's say we are having paneer, and you want the paneer to be hot from inside. If you're looking for tandoori paneer right now, it's so good, right? Even my mouth is watering right now. Acha, so let me know. Does it take few minutes or few hours? That is what we're talking about. Now, I will not go towards hours, but yeah, few minutes and hours. So minutes till hours is where we're talking about the moderate reactions. Okay? And now, when we are going to talk about very slow reactions, what are we really looking at? We're looking at months. We're talking about April. We're talking about May right now. We're talking about June, July, August, September. What is exactly happening? This is a sheet of metal. This is a sheet of iron which is actually catching rust. Can you see the formation of rust, boys and girls? And it's taking actually months. So whenever we talk about reactions which are going to take days / months to get complete, these are going to be very slow reactions, right? How do we get to know? Totally based upon how much time these reactions takes to get completed. 100% is, 98% of completion. Rusting of iron is one of the examples. Okay? And now over here you should remember, how do we get to know how fast a reaction is? Everything is going to revolve around a single word, which is the rate of reaction. How fast? What is the rate? I'm not talking about the price. You go to the shop and you say, what's the rate? What's the rate of onions, or what's the rate of anything, right? That's not the rate we are talking about. We're talking about the speed. We're talking about how much concentration changed. How much there is a change in concentration. That comes on the numerator, and how much time it took. When the change in concentration is big, when the amount of reactant changed is more in very less time, in 5 seconds there is huge amount of reaction which changed its concentration in very less time. Is it good or bad? There's a shop which actually makes 5 burgers in a minute, and there is a shop which makes 10 burgers in a minute. Which one is better? Which one is fast? Not better. Let's not talk about the quality. Which one is fast? Which is having a higher rate of production of burgers? It's actually going to be the one which is actually making burgers, n number of burgers in lesser time, right? So lesser the time, higher the change, that is going to show you better rate. So do remember this. Clear? Very easy, right? It's very, very, very easy. Yes or no? Now, let's talk about the formula, and you should also remember, whenever we talk about change in concentration, that is going to be concentration which is final minus concentration which is going to be initial upon the change in time. Let's talk about delta T. And now you should remember, whenever you have a concentration, can the concentration term be molarity? Yes, it is going to be molarity. Let's talk about molarity. And now pay attention. Let's say the initial final concentration is 10 molar. Initial concentration is 5 molar upon time. It could be second, it could be hours, it could be minutes, it could be years. We don't care right now. Molarity minus molarity, whatever the answer is going to be in the numerator, is it going to be, it's going to be 5, but what will be the units? What will be the units whenever you are subtracting molarity minus molarity? Tell me, the units remain same, right? Even that is going to be molarity, correct? So for the rate, in the numerator, what is the unit? Molarity upon per time, which could be per second, per minute, per days, per month, per hour, or per year, something like that. Okay, so you should remember, whenever we talk about rate, there is a unit which is molarity second inverse or molarity minute inverse, molarity hour inverse, something like that. Clear? And the unit of the molar, this rate in chemical kinetics is never going to change. And this will always help you to know the rate, the units of other, particular constants or whatever we are going to talk about. Okay. And now guys, pay attention. We are actually going to have an example. So over here, what are we really talking about? We are actually talking about when 1 mole of N2 and 3 moles of H2 is giving you 2 moles of ammonia. And let's say this reaction takes 30 minutes to complete. Let's say this reaction took 30 minutes to complete. Okay? Now guys, you let me know. Where do you see the consumption of the substance is more? Consumption. In 30 minutes, let's say 3 moles of H2 were getting consumed and 1 mole of N2 was getting consumed. Where do you think the consumption per time is more? Which one is getting exhausted quicker? Let me know. What will you say over here? Is it the hydrogen or is it the nitrogen? Instantaneous reaction. When I open my lunchbox in school and getting attacked is from, yes, amazing. Correct. Let me know. Where do you think the consumption is more? Let's talk about this. So let's say you're the one which actually eats 5 burgers and 5 burgers in 30 minutes or 2 pizzas in 30 minutes. In which particular scenario the consumption of yours is more? I'm talking about in numbers. In which scenario do you have higher consumption in numbers? It's going to be where you consume more material, right? Over here, as 3 moles of hydrogen is getting consumed in 30 minutes and over here 1 mole of nitrogen is getting consumed in 30 minutes. So the rate of consumption is higher over here. Rate, I said rate. Why? Because 3 moles of hydrogen became 0 in 30 minutes. Over here 1 mole of N2 became 0 in 30 minutes, right? So you should remember it. Here the numerator becomes bigger. 3 moles to 0. And 0 which is final and initial which is 3. So do remember this. But now let's talk about individuals. Okay. So when we talk about rate of disappearance of hydrogen, what will we write? Same thing. Change in concentration upon change in time. How much concentration did we change and how much time? Do you see a negative sign? Yes, because you should remember, always it's going to happen. Whenever we're going to talk about reactants, they will be always having higher quantity, some extra quantity, let's say 10 molar, 20 molar, 5 molar, 1 molar, whatever number. But as we talk about, the time goes off, their concentration always decreases. Let's say from 5 molar to 1 molar. The concentration, this is initial, this one is final. So whenever you will talk about change in concentration of the reactant, what is going to happen? You will always write the concentration which is final minus the concentration of reactant which is initial. Over here you will write 1 minus 5, but your answer will come like minus 4. But you should always remember, whenever we talk about rate, it's a positive quantity. Okay, it's a positive quantity. It's like speed. You can only talk about the value. You can never talk about the minus. We can never talk about the direction over here right now by looking at just the number. Okay, so negative rate is what we are not going to talk about. If we want a positive value, then what will happen? Now guys, pay attention. Over here, if I have to calculate rate, it is going to be change in concentration of reactant, which is minus 4 upon, let's say it took 10 minutes, but you should multiply it by minus, because minus into minus will become plus, and the value of rate should be positive. Is this clear to each and everybody? Come on, let me know. Rate has to be always positive. And now this is the reason, whenever we are going to talk about, see, reactant, product. Whenever we're talking about reactant and reactant, you will always see a negative sign in front. The reason is what you know it right now. When we talk about the case of product, it is always going to be positive, or even if you wouldn't put positive sign over there, even that is fine. Yes, amazing, Lakshika. And now let's talk about more. Over here, guys, pay attention. What are we talking about? The rate of reaction. See, these are the individual consumption values, whatever you guys are going to get. But what is the rate of the overall reaction? We cannot say this is the rate of the overall reaction. This is the rate of the consumption of particular substance. Okay, so it's like in a minute, let's say I say in a minute you ate 5 burgers in 10 minutes. Okay, and apart from this, if given you a pizzas, in a minute you will eat, in 10 minutes you will eat 2 pizzas, but that actually doesn't tells the exact rate of the reaction. For that, we are going to take care of the stoichiometric coefficients. Okay, we'll talk about this. So what are the stoichiometric coefficients over here? Over here we have 1, over here we have 3, and over here we have 2. So whenever we are going to talk about the rate of reaction, how will you write, guys? Do this with me. Okay, let's talk about a reactant over here. Change in concentration. For concentration, put square brackets upon change in time, but as it is a reactant, minus sign. Do remember, the stoichiometric coefficient comes at denominator. Okay, is equals to minus. Why minus? Because of the reactant I'm talking about. Change in concentration of H2 upon change in time. What is the stoichiometric coefficient? 3. Stoichiometric coefficient comes in the denominator. And when we talk about the change in concentration of ammonia and the rate of reaction, that is going to be change in concentration of NH3 upon change in time. A positive sign over here, but where should I put this 2? In the numerator or in the denominator? The answer has to be in denominator. So this is what you have to remember. These stoichiometric coefficients are going to come in the denominator. What if there is there's any particular substance where the stoichiometric coefficient, let's say, is half. Then instead of putting 2 in the denominator, you'll put 1 by 2, where then 2 will come on the numerator side. Okay, you have to do this reciprocal. Do remember that. And anyhow, we will do some type of questions over there, okay, in this particular class itself. So now, this is what it is going to be, okay. Half change in concentration of NH3 upon change in time, minus and minus. So this is where 1 is. So do remember this, okay. Clear? If yes, give me some smileys in the chat and we will move ahead towards the next topic. And anyhow, today's topic is going to be the rate of reaction and the order of reaction, the molecularity of reaction. We are going to talk about a lot of terms. We are going to discuss a lot of terms, where in the next class we will not discuss anything about, related to all of these, and we will actually dive into much great concepts. So now guys, pay attention. We're talking about two rates. We're talking about average rate of the reaction. We're talking about instantaneous. In the case of instantaneous, this delta T is very small. Let's say a reaction takes 10 minutes to get complete. 10 minutes or 1 hour. Okay, 1 hour to get complete. Whenever we talk about the instantaneous rate, we actually want to know within 1 second how much concentration changed. Something like this. So if this is where, this is the initial rate, initial concentration of reactant, that is naught, okay. So naught represents, see, this is how it is, concentration of reactant, concentration is the square bracket, this naught means the initial concentration. This is the one, which could be any specific value, whatever you like, 10 molar, 20 molar, 1000 molars, whatever. Now, this is where we can actually say that the reaction is complete. It can no more further decrease the concentration. This from here till here or till here, it takes 1 hour. So whenever we are going to talk about the average rate of reaction, what are we going to do? We are simply going to take, let's say, time 0, time 1 hour, and we will see how much concentration entirely changed. In other words, the delta T that we talk about is big. The delta T values are large. When we talk about delta T values in the case of instantaneous, it's small. Something like, if you are really want to know the rate of reaction at a particular very small T, okay, very small, or maybe even smaller than this. Maybe if you want to know the change in concentration between these two, 1 second and second, after 25 second and 26 second, between that, how much rate change, how much concentration changed? This much. This is going to be your dr. Okay. So when we are talking about very instantaneous changes in the concentration, then only we are going to talk about instantaneous. But when we talk about average, this is anyhow what we are learning. We're talking about initial minus final minus initial. Let's say this is 10, let's say this is 2, and how much time did it take? 30 minutes, 1 hour, whatever the time is going to be. Always remember the denominator is always going to be positive. The denominator is always positive because the final time is always, T2 is going to be always greater than T1, because time never stops, right? And time is never reversible. Time never stops. So this is what you should remember. In the case of denominator, it's always positive. When we are talking about reactants, the numerator is negative. Then only we put this negative sign, okay? And when we talk about the case of products, it's always positive, so we do not have to worry about the negative sign, okay? Reactant goes on decreasing with time. Absolutely correct. That's the only reason whenever you see reactant, the initial concentration and whatever final concentration you want to talk about, whether this, it is always going to be lower, lesser than what you actually started with, okay? And now what are we really talking about over here? Over here, do you see the product, the concentration is increasing. On the y-axis, we have the concentration of product. On the x-axis, we have time. What are we starting with? We're starting with the concentration of product, which is 0. And in a lot of cases, and in a lot of scenarios, the concentration of product at initial stage at t is equals to 0 is 0. When t is equals to 0, this is where we're talking about initial concentration of product, which is 0. With time, the product forms, right? After some time, product forms. This is how, let's say, the concentration is changing. Whenever we will talk about the rate of the reaction, instantaneous one, you will always take very small change in time, and you will see this is the concentration of product, and this is the final one. This is the change. And in the case whenever we're going to talk about the rate, instantaneous rate, this delta p, this dp is always going to be smaller. So again the same thing, okay, but the only point that you have to remember that over here there is no negative sign. Why? Because always remember P2 is greater than P1, PF is greater than PI. I'm talking about the concentrations, because concentration of product always increases with time. Is this clear to each and everybody? Come on, give me a quick thumbs up and let's move ahead. And this is where we are going to get into a question, and this is how you should read the question, okay? Pay attention. The decomposition of N2O5, that means the molecule is anyhow going to just break into smaller molecules. This is what decomposition is. We have the reaction N2O5 giving you N2O4 plus half O2. Do you see the stoichiometric coefficients? You should make sure that you actually see them or mark them. It's 1, it's 1, and it's half. Do note it down. Half of the things are done over here, just because you actually spotted the stoichiometric coefficients very well. Now guys, pay attention. In a certain time interval, after some time, the rate of decomposition of N2O5 is given to you. Rate of decomposition means by the rate it is getting consumed, exhausted. Let's write it over there. What are we really talking about over here, guys? See the units as well. Moles per liter, which is molarity per minute, which is the rate of disappearance of N2O5. How will you write this? This 1.8 into 10 raised per minus 5 is for change in concentration of N2O5 upon change in time. Clear? What will be the rate of formation of NO2 and O2? But the rate of the reaction is never different, right? It is going to be the same. So what will you write? Guys, write this with me. The rate of reaction is going to be change in concentration of N2O5 upon change in time. Is this a reactant? Yes. Put a minus sign. What is the stoichiometric coefficient? 1 is equals to, what is a product? This is a product and this is a product. Change in concentration of N2O4 upon change in time. Is it a product? Put a positive sign. Stoichiometric coefficient 1 is equals to change in concentration of O2 upon change in time. What is the stoichiometric coefficient? Half. What will happen over here, boys and girls? If you put half over here and if you just do the reciprocal, because if we have to bring things to numerator, we can bring things to numerator over here. It will become 2 by 1. This is what we will see. Correct? Now guys, pay attention. what we are talking about is rate of formation of NO2, and we are talking about the rate of formation of O2. ठीक है ना? So this is what we actually have to remember. You should also remember, so this is how it is going to be. ठीक है? Pay attention. Over here, if you are really going to look into that, this is N2O4, and you should remember N2O4 is nothing but 2 moles of N2O, NO2. So now, if I make some changes over here, how will I write? It's going to be 2 moles of NO2, which I will make over here as NO2, and this becomes 2. Correct? Some more changes, and now what are we going to do? What values do we have? We have this value. We have this value, which is 1.8 into 10 to the power minus 5. Ultimately, simply multiplied by 2, you'll get the rate of formation of NO2, and simply divided by 2 and you'll get the rate of formation of O2. So 1.8 10 to the power minus 5. So for the rate of formation of NO2, it is going to be 3.6, and for the rate of formation of O2, it is going to be 0.9. That's how it is going to be. Okay? Yes. So 0.9 for the oxygen, and yes, 3.6 for the same value. Okay? So this is what you should remember. Okay? Boys and girls, let me know. Come on, come on, come on. Yes or no? Good, right? Chalo. Now let's move ahead. Now we are going to talk about the law of mass action. So where have you seen this law first? This law isn't taught to you in class 12. This law had been taught to you in class 11th. The chapter is chemical equilibrium. So law of mass action. What is a mass action? This is nothing but concentration. So do remember this. This is all about concentration. And what is the easiest formula of concentration? Number of moles upon volume. Right? This is what we are going to talk about. The active mass. The active mass that we are going to talk about over here is the concentration actually. Okay? And molar concentration by of the substance, which is having a formula which is N by V. So do remember this. Okay? Yes. Hi Pragya. Hi Vinay. Welcome to the session. And now what are we are looking at over here? Whenever we have A moles of A, where small a is the stoichiometric coefficient plus small b into B, stoichiometric coefficient giving you small p into P, where this is a stoichiometric coefficient which is a product. You should remember, according to law of mass action, which is a theoretical law, which is not always correct. We are going to talk about an experimental law today, which is the rate law. Okay, the law of, we are going to talk about that. Okay, so now pay attention. What do we write for with this? The rate of reaction is assumed to be as the concentration of A, concentration of B, and the stoichiometric coefficients at the power. This is what it is. This is directly proportional to. Okay, when we have to equate it, R is equals to K B. Is this clear? And do you remember the equilibrium constant, the Kc that we talk about? Kc used to be always the forward reaction, the rate constant of forward direction and the backward direction, and this is how you used to get the formula. Okay, we're not diving there today, but this is what you have to remember. This is the rate expression according to law of mass action, but this is a theoretical law, okay, which is not at all correct, if we compare it with the other law that we will discuss. And now over here, the rate law. Rate law is an experimental. experimental law. And why is there an experimental law? Because everything remains same. Rate is equals to the rate constant, concentration of A, concentration of B, but it is not having the power which is equals to the stoichiometric coefficient. In the previous case it was A and B which were the stoichiometric coefficients. Over here it's not A and B, it's something other than the stoichiometric coefficients. And how do we get to know these powers? Values of M and N are calculated experimentally. And will you be able to calculate this in this chapter? Yes. There is going to be a class, third class, where I am going to teach you how to calculate the M and the N values with the given experimental data. Okay, and now guys pay attention. So do you see the stoichiometric coefficients? This is not the same thing. So do remember that. There have been few cases, very few cases, where the value of M and N is same to the value of A and B respectively, but it's just coincidence. Okay, they're not linked is what you have to remember. Okay, is this clear to each and everybody? Let me know. And now over here let's talk about the statements over here. The rate law represents the experimentally observed rate of reaction, which depends upon the slowest step of the reaction, which clearly depends upon the slowest step. That means which all reactants are taking place, which all reactants are coming together when the reaction is taking place, and how much time do they take. Okay, so do remember that the rate law cannot be deducted from the relationship given by the equation that we were looking at, the previous one. Okay, and now over here what are we really looking at? It's a very easy thing. So over here what are we really looking at? We are looking at the concentration. Here, concentration at T is equals to 0. Guys, can I write this is T is equals to 0, which is having some value? It is always going to be the initial concentration of reactant. And when we talk about the value, the concentration value, which is either going to be 0 or very much minimum, this is going to be the concentration of product, but the initial one. So do remember this. And what exactly happens with time? The concentration of reactant decreased, the concentration of product increased. Okay, can we have some different types of graphs as well? Yes, I'll show you. Is this a good graph? Is this acceptable? So on the y-axis I'm having concentration, on the x-axis I'm having time, and I'm doing it like this. So concentration of reactant decreased, concentration of product increased. Is this fine, boys and girls? Let me know. Will you accept this graph if I show this to you? And is this possible? Again concentration, again time. This is the concentration of reactant. This is the concentration of product. Can the concentration of reactant and the concentration of product be same at after so many minutes or hours, whenever the time gets completed, whenever the reaction gets completed? No sir, they must interact. It's not like that. All the three types of graphs are acceptable. Do remember this. Intersection means equilibrium state. No, Lakshika. Whenever you're talking about the equilibrium scenario, you should remember the rate of the backward and the forward reaction should be same. So if you think that this is the state of equilibrium, no. All the three graphs can also show you equilibrium. When the concentration of reactant and product do not change, then we can say that the things are in equilibrium. So if you know, the graphs saturates, now they don't change, then ultimately equilibrium is achieved. Here itself, equilibrium. Here itself, equilibrium. Here itself, equilibrium. So equilibrium can achieve, equilibrium whenever it has to achieve, it's all depending upon the rate of the forward reaction and the backward reaction. They both should be equal. They really do not care about, you cannot just look at the concentrations of the reactants and products and tell whether it's, you know, it has achieved equilibrium. Do remember that. The only reason I'm showing you these graphs so that you can be the smarty pants. Okay. And over here, this is all possible at the, you know, whenever the time, you know, after 2 hours, 4 hours, whatever, there can be a scenario where the concentration of reactant and product is same. It's also over here. See this point. And this could be that the reaction stops when the concentration of reactant is still more than the concentration of product, what I showed you there. And there could be a scenario where the concentration of product becomes higher than the reactant and reaction stops here. Different reactions is what I'm talking about. All the 3 graphs are acceptable. Do remember that. Okay. And now, rate law and law of mass action, theoretical law, where, you know, stoichiometric coefficients A and B were taken as power, right? Experimental law, which is actually very much acceptable, applicable everywhere. Okay, where these N and M, the powers, are not equals to A and B, and if by any chance they are, it's a coincidence. That's it, is what you have to remember. Okay, this law depends upon the concentration terms, and this one actually over here is dependent upon the stoichiometry. So stoichiometry never always helps. Okay, experimentally you should know the concentration, how concentrations of different reactants change with the given period of time, and then only we get to know. Are we going to do this? Yes. Is it today? No. In the next class. Okay, but is the class over? Not at all. So we are moving ahead. Okay, so what are these M and N? So there is a term known as the order of reaction. So you should also remember how quickly can we find the order of reaction. So if you have, let's say, a the rate law expression, we're not going to talk about law of mass action from now. So we are only going to talk about the rate law expression. This experimental one is equals to K, concentration of A raised to power M, concentration of B raised to power N, and let's say concentration of C raised to power O. Okay, guys, pay attention. I am talking about AA plus BB plus CC giving you product. You have to write all the reactants. So that's the reason I extended this. I can do it with both of them as well, but I'm giving you something extra. Over here, whenever you have to calculate the order of reaction, just do one thing. You see these powers? Add them up. M plus N plus O. I'll do it like this, okay? So this is the order of the reaction. If you have just 2 reactants, M plus N. If you have 1 reactant, that same, the power A raised to power M is going to be the order of the reaction. Okay? There are times where the concentration of the other reactant is not much helpful. There will be a lot of time, and we will talk about it. Okay? When we will dive more into the order of reactions, we will talk about different examples: 0 order, 1st order, 2nd order, and so on, nth order. Okay, guys, pay attention. Hoo hoo ho ho, ha ha, he he. Leave it there. Okay, chalo. So, but anyhow, can the question ask you what is the order of reaction with respect to a particular reactant? Yes. With respect to reactant A, it's M. With respect to reactant B, it's N. Can the value of M, N, or the order of reaction be 0? Yes. Can it be in fraction? Yes. Decimals? Yes. 0.5 can also be the case. Can this value be 0? Yes. Can this value be positive? Yes. Can this value be negative? Yes. So it can be any number, not the irrational numbers. Okay, so do remember that. We're not going to talk about the irrational numbers. I mean, we are going, no, not the irrational. Irrational numbers can also be there, but what I'm talking about is the imaginary ones, not the imaginary ones. Okay. So now, over here this can be a negative fraction or a zero value or a positive. So do remember this can be any number which you can think of, not the imaginary ones. And now over here let's do a question. Okay, calculate, it's very easy because it's very easy. Calculate the overall order of the reaction which has the rate expression as. So rate is equals to rate constant, rate is equals to rate constant, a raised to power half, b raised to power 3 by 2. Just do one thing, half plus 3 by 2 is going to be the order of reaction. Give me the answer. 1.5 plus 0.5. 2. 1. Seriously. 3 by 2. It's 3 by 2, which is 1.5 plus 0.5, which is 2. Right, Lakshika? Okay, do not remove the messages. Okay, so now let's talk about 3 by 2, which is going to be 1.5 and minus 1 plus minus 1. The answer is going to be 0.5 or half. This is the order of the reaction, half. For the first one, it's 2. Do remember this. 1 by 2 dikha, koi baat nahi, it's okay, it happens. My mistake, next time I'll keep the digits bigger. Okay, and now let's talk about more. So we are talking about actually the unit of rate constant, which is having a good weightage. A lot of time this has been asked, and in a lot of cases the question will give you the units of the rate constant and you have to think which order it is. So guys, pay attention. What is the unit of rate? I taught you in the initial stage of the class. What is the unit of rate? It never changes, I told you. It's always, let's say, molarity per time. So I'm writing per second. Okay? Per minute, per hour, per year, whatever. But for this case, we're taking per second. Now, you should remember, whenever I'm writing is equals to K, and there is concentration, and which is having a power 0. What is the order of the reaction? 0 order, correct? Now guys, pay attention. So concentration raised to power 0, this becomes 1, just 1, dimensionless, right? We have K, which is the rate constant. Then what is the unit of rate constant? As same as the rate. Then over here the unit of the rate constant, if we are having a 0 order reaction, it is going to be same as the unit of rate, which is going to be molarity per time. Do remember this. Guys, pay attention. Now when we are talking about rate is equals to rate constant A raised to power 1. We're talking about first order reaction. What is the concentration over here? I mean, what is the unit over here? Molarity raised to power 1, rate constant. What is the unit over here? It's going to be molarity per second. Can I write this as molarity? Molarity raised to power 1 is molarity. Molarity getting cancelled. The unit of rate constant when we have first order reaction is per second. Second inverse. Per second, second inverse, or minute inverse. That is nothing but time inverse. So whenever the question gives you that the unit of the rate, the rate constant has a unit 2 into per minute, then you should know that the question is talking about the first order reaction. Okay, let's talk about the second order reaction. Rate is equals to K, concentration of A raised to power 1, concentration of B raised to power 1, or it can also be written as concentration of A raised to power 2. In both the cases, the order of the reaction is same. The rate has a unit, molarity per second, rate constant, and over here molarity square, right? So now guys, pay attention. I can write this as molarity square over here. We have one molarity. Let's cancel. Let's take m on the LHS. So the rate constant will have a unit. Second inverse, molarity inverse. So does the concentration, does the unit of the concentration of reactants changes? No, it always remains molarity. Does the unit of rate changes? No, it is always molarity upon time. But when we change the order of the reaction, not we, when the order of the reaction is different, K, rate constant, has a different unit. Clear? Now pay attention, boys and girls. Do we have a formula? Yes. But do I recommend you learning a formula and keeping it, just thinking that you are actually memorizing it? No. Always do this. It just takes 5 seconds in a examination hall and you will always know the exact unit of rate constant. But yes, if you want to, then ultimately just know rate upon concentration. I can write this. See how I am going to write this. K is equals to molarity per time, which is the rate, upon concentration raised to power m plus n. Because this is concentration, this is concentration. Concentration raised to power m into concentration raised to power n is going to be nothing but concentration m plus n. The powers will get added, right? And this is what you have to remember. Whatever is the order of reaction, this is going to be the order of reaction. So whatever value they give you, just keep it over there, 0, 1, 2, 3, whatever. You have this, which is the concentration, this is the unit of the rate, and just do this. You'll always get the unit for the rate constant. Okay, Abhirami, bye-bye, take care. Is this clear? Come on, let me know. And yes, hit the like button if you're liking it, if you think that you're learning something. Okay, and now, simple. The most asked units, it's for 0, first or second. In the case of first, it's just per time. In the case of 0, it's as same as the rate of reaction, molarity per second. And in the case of second, molarity inverse per second. Molarity inverse, second inverse. Abhirami, it's okay, don't be sorry, take care. Sir, kal NEET ka hai 2021 students, next year mine. Yes, all the best, Khushi. Good, right? Now, let's talk about this. Over here, we're talking about molecularity. Molecularity just talks about how many particles, how many molecules, how many species came and they have to actually collide in order to form a product. They have to anyhow come, otherwise the product cannot form if these two particles do not collide. So now guys, pay attention. In the first case, there shouldn't be any collision. Simply one particular molecule is getting decomposed. Correct? How many particles do we require to get the product? Just one. It's a unimolecular. Molecularity over here for this reaction is 1. Let's talk about second. I need one molecule H2, one molecule of I2, and then only I'll get the product. How many molecules do I need to get this particular reaction? 2. Anyhow, the molecularity of this particular reaction becomes 2, which is bimolecular. Now let's talk about the case second one. Over here I need 2 and I need 1 to get it, and the molecularity over here comes out to be 3. And which is very much easy to, if you see the reaction, you'll get to know how many molecules are actually coming up and interacting in order to get the reaction. That is going to be the molecularity. Is this clear? Obviously, Lakshika, even that is correct. But to be very honest, there are a good amount of formulas that you always have to remember when it comes to chemistry. They simply, a student who's having a good IQ, he or she might not be going for, should not go for memorizing this formula, which is very much easy. You just need to do what? In the last case, you just have to remember the rate law expression. R is equals to K, A raised to power order of the reaction. That's it. You can do it always, right? Amazing. Now let's move ahead, and over here we're talking about a question. Guys, pay attention. There are 4 options given to you, A, B, C, D. The rate constant for the reaction where 2 moles of N2O5 giving you 4 moles of NO2 and O2 is given to you as 3.0 10 raised per minus 5 per second. Per second. What are we talking about? Rate constant. You should be the one who writes it then and there. Here as well, write it. This is the value of K. What is the order of the reaction? What is the order of the reaction? If you cannot guess the order of the reaction correct over here, you should not move ahead. You will do it wrong. Okay? Though this question is not going to use this particular value ahead. I mean the unit, the order, but yeah, still tell me. Let me know. What is the order of the reaction? Whenever you are having the unit which is per time, per second, per minute, per hour, whatever, the order of the reaction over here is going to be first order. If the rate is given to you as 2.4, see, anyhow what I see is 10 raised per minus 5, 10 raised per minus 5. This is 2.4, rate is given to you as 2.4, K is given to you as 3.0. Then the initial concentration of N2O5 is going to be. Formula is R is equals to K N2O5. That is the only reactant. What is the power that you are going to put over here? It's the first order. Right? Rate value 2.4 into 10 raised per minus 5, 3.0 into 10 raised per minus 5. And this is the concentration of N2O5 that you are trying to calculate. 10 raised per minus 5, 10 raised per minus 5 getting cancelled. That's the reason I have thought of going with 2.4 and 3.0. And the correct answer over here is going to be, yes, it's going to be D. 0.8 is going to be the correct answer. Clear? Yes, Lakshika and Pragya, absolutely correct. It's 1. And by the way, guys, you should just know today Captain Luv, aka Pragya, is actually having, it's her birthday. It's her birthday, so you should definitely wish her in the chat. It will be amazing, right? Even it's her birthday, she should be celebrating. She's actually coming up over here and taking up this class. Wow. Is this dedication? Or is it like she had all the fun for the whole day? Maybe she can tell us. Okay. Now, this is where we are absolutely at the end of this class. This is the end where I am going to ask you to ask a doubt if you have any. Though with my level of teaching, no student can have a doubt. No student can have a doubt if he or she is watching since starting till the end. But ultimately, if you have any doubts in physics or mathematics as well, so over here, ask a doubt anytime, unlimited doubts, and in return you'll get high quality video solutions in English and Hindi. Do make sure that you actually click a photograph or take it from a gallery, crop it properly. The question, the options, everything should be clear, whatever it takes to solve a question. And no handwritten material, no 2 questions should be there in the same particular photograph. And send it to us, you'll get a reply. That's it. Make sure the image is clear. Whenever you click, there should not be any flash. Things should be clear. That's it. And yes, Yava sir is best. Absolutely. Even if Yava sir is teaching you and if you do not have a doubt, just go for maths. Asking doubts. Use this feature for each and every subject, even for chemistry. So yeah, over here. And also remember, for the scholarship, do not forget to use the code LOVEGURU whenever you have to enroll for a free test which happens every Sunday 11 AM. Enrollment is free. Rank 1 holder, 2 holder and 3 holder gets the 100% scholarship for 1 year. Do remember this, okay? The name of this particular scholarship test is Combat, and every student should give it if you are looking for starting your preparation, for a 1 year or a 2 year long term program. Do remember that. All the best. Take care. Bye bye. Tata. Let's meet again.